Hi everyone, I am Arhan, and here is my microwave engineering term project, high frequency low noise amplifier. Here is the requirements of the project. The center frequency should be at 1.19 GHz with a 10% fractional bandwidth. The gain has to be larger than 8.265 dB. The gain variation should be less than plus minus 0.5 dB. The input return loss has to be greater than 8 dB. The output return loss has to be greater than 12 dB, and the noise figure has to be less than 1 dB. We have used Advanced Design Systems schematic and layout editors for this project. This is the first schematic we built using lumped components. The DC bias circuit can be seen on top, the input matching circuit can be seen on the left, and the output matching circuit can be seen on the right. This is the second schematic we built using transmission lines. We have changed the series inductors to high impedance series transmission lines, and we have changed the shunt capacitors to shunt open circuited transmission lines. Here is the final schematic that we have designed. We have changed all the transmission lines to microstrip lines. Here is the simulation results for our circuit. The step factor is above 1 at all frequencies. This shows that our circuit is stable at all frequencies. Here is the S parameters of our circuit. Here is the noise figure of our circuit. Here is the summary of the simulation results. As can be seen, our circuit satisfies all the requirements of the project. Here is the layout of our circuit. We have placed pads for SMA connectors on the input and output sides. We have also placed additional pads for the supply connections. Here is our soldered circuit. Here is our test environment. We have used a network analyzer to measure the S parameters of our circuit. Here is the S parameters of our circuit. We have used a noise figure meter to measure the noise figure of our circuit. The measurement can be seen here. Here is the summary of our test results. We have achieved a gain of 8.4 dB with a gain variation of 0.94 dB. The input return loss was around 14.5 dB, while the output return loss was around 17 dB. The noise figure was around 0.97 dB. As you can see, the circuit satisfies the requirements of the project. Thank you for watching my video.